Find the radius of convergence for this weird looking function. It's kind of weird. So how are we going to do this? We're going to do the ratio test. What is a ratio test? It says the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. Whenever that's less than 1, the series converges. Whenever the next term over the previous term, that ratio is lower than 1, that means the next term is smaller than the previous term. The terms are getting smaller. They'll add up to infinity to be a finite sum. It'll converge. Okay, so let's do it. So let's take the limit as n goes to infinity. So we need a sub n plus 1. What's that? Well, I'm going to write it out. On the top, that's going to be, 2, 4, 6, to n plus 1. 2 to the n plus 1. Write that better. Here we go. Over 2 to the n plus 1, whole thing, factorial. Okay, now that's going to be over, right? Because that's a sub n plus 1 over a sub n. What's a sub n? Well, same thing, 2, 4, 6, to the 2n over 2n factorial. But we don't want fractional over fractional. Let's flip that upside down and multiply by the upside down. That's easier. Dividing is multiplying by the upside down. Same thing, right? So we'll go times, and we'll do the other one, which is what? Upside down, so it'll be 2n factorial on the top, 2, 4, 6, times 2n on the bottom. Absolute value of that, less than 1, series will converge. So, okay, so let's find out. Oh, I forgot about the x sub n. So the first one should have had x to the n plus 1, then we flipped it upside down, so there should be an x to the n on the bottom. All right, right? Forgot about that guy. All right, so now what's going to happen? Well, let's write this out here. This is 2n plus 2, right? When I distribute this, boom, boom, 2n plus 2. Notice these are going by even amounts. So really, you could write out that top like this. You could say, look, it's 2, 4, 6, all the way to 2n, right? And 2n plus 2. Because the term right before 2n plus 2 must be 2n because they're going down by 2 or up by 2, whichever way you go, right? Going up by 2, so that way down by 2, right? On the bottom, we've got, what is this? 2n plus 2 factorial. Now, what does that mean? That means 2n plus 2 times 2n plus 1 times 2n factorial, right? Because, for example, if I had 7 factorial, I could write that as 7 times 6 times 5 factorial the rest of the way down. You could peel off a couple of them and then give the factorial to the rest of it. That's what I'm doing here. 2n plus 2 factorial means 2n plus 2, go down by 1, 2n plus 1, go down by 1, 2n, and then factorial the rest of the way. Why am I doing that? I want it to cancel with that 2n factorial in the blue, the other one. So that's the method to my madness here. So 2n factorial, that's going to cancel that, you see? Oh, x to the n plus 1 here. I'll put the x's over here. X to the n plus 1 is, you know this, right? We do this every time. X to the n plus 1 is x to the n times that, and this is x to the bottom. They're going to cancel, right? Because n plus 1 is x to the n times x to the 1. Let's cancel. All right, easy peasy. Now, what about right here? This is 2, 4, 6, 2n, and see what's going to happen there. This is going to cancel up to there. Absolute value less than 1. Less than 1. Okay, so see how I got some nice cancellation to happen? So what are we left with? Limit n goes to infinity of, what do we got here? We got 2n plus 2. Now circle, either cross off or circle everything. So I'm going to circle this guy. He's left over on the top, right? Whereas the rest of the stuff canceled, right? See how this canceled up to 2n, canceled up to 2n, and the 2n factorial canceled, 2n factorial canceled, xn canceled. So what else are we left with? I'm left with 2n plus 2, 2n plus 1 on the bottom. I'll circle them just so I don't lose anything. I either circle or cross out everything so I don't lose anybody. And times x to the 1 absolute value less 1. See, I circled or crossed off everybody. Didn't lose anybody. Okay, now we're going to go to infinity with this thing. What's going to happen when you go to infinity? Well, Um, I don't know. Oh, so yes, I do. So this is going to be the limit as n goes to infinity. So what is this going to do? Well, remember, all that matters is the highest power term when you go into infinity. Going to infinity. All that matters is the highest power term on the top, highest power limit. So it's really going to be 2n over, and if you multiply these guys, 4n squared times x, absolute value, less than 1. That's all that matters. When you're going out to infinity, if you go 2 times infinity plus 2, the plus 2 is nothing, right? Same thing here. 2n plus 2 is nothing, plus 1 is nothing. It's 2n times 2n is 4n squared, okay? Simplify that, and I get the limit and goes to infinity. This cancels that, and 2 goes into 4 two times. So we get 1 over 2n times x less than 1. Now we go, now plug in the infinity. We're going to infinity. So that's 1 over 2 times infinity times x, absolute value, less than 1. I don't write the limit out there anymore. I did the limit. What's 1 over 2 times infinity? 1 over infinity? That's 0. So that 0 is less than 1. So that means any x value, right? X can be anything. You could let x be anything. You can let x be a million. And 0 times a million will be less than 1. So x can be any value. X, the radius, is infinity. X can go as big as you want because, whoops, what is the problem here? Erase that. There we go. The radius is infinity because this went to 0, and 0 times any number is going to be less than 1. So there we go. Radius is infinity. It is true. And so there we go.